In this video, I'm going to be discussing how to find sample size when we're trying to estimate a population proportion. And I'll be discussing example 8.14 from the free online introductory statistics textbook, which you can download via this link here. And I'll be using Microsoft Excel as my calculator. All right, let's get started by reading through the example. We have a mobile phone company who wants to determine the current percentage of customers age 50 and above who use text messaging on their cell calls. So they want to know a percentage or a proportion, okay? And they haven't yet collected any data. They want to know how many customers should they sample to be 90% confident. So they want 90% confidence that the estimated sample proportion is within 3 percentage points of the true population proportion, okay? So they have nothing yet, right? But they're going to get a sample proportion. And if they go 3 percentage points to either side of that sample proportion, so 0.03, 3 percentage points. Don't forget to change that over to a proportion, right? To either side, and they construct an interval. They want to be 90% confident that the population proportion P is somewhere inside of that interval, okay? So, how many people should they sample to have that 90% confidence? Okay, that's what we need to figure out. So let me scroll down. There is a formula for this. N, which is the sample size, equals Z alpha divided by 2, or you might see that written as Z subscript C. If you see it with a subscript C, don't worry, it's exactly the same thing that I'm going to be talking about. I like the notation alpha divided by 2 though, so I'll leave that. All right, times P times Q divided by E. All right, and Z is squared and E is squared. All right, so that's the formula. All right, so let's go through this piece by piece. First, what is Z? Z is entirely dependent on your confidence level. So if I were to draw this out, here's our normal distribution. In the center we have 0, right? We want 90% in the middle. The confidence level is 90%, right? If the confidence level was 95%, we would have 95% in the middle. Z alpha divided by 2 is with these cutoffs. So this is the negative because it's less than 0. It's on the left side of 0, and the positive is on the right side of 0. All right, so how much is left over in the tails? What's alpha? Alpha is 1 minus 0.90, which is 0.10. Okay, so then alpha divided by 2 is 0.05, right? So in each tail is 0.05, right? There's 0.1 in both tails, but in each tail, if you divide that in half, there's 0.05 in each tail. Okay, so given that, I can figure out what Z is. So let me go to Excel. All right, and I want to use that norm.s.inverse, right? S stands for the standard normal distribution, the normal distribution that's centered on 0 with standard deviation 1, right? So open parentheses, and what I want to give it is that alpha divided by 2, or that 0.05, okay? And it's always going to give me a negative number, right? Because it's the negative side that it's giving me, this side over here. So I always want the positive, so a negative and a negative make a positive, so I could put a negative sign there, and there we go. That's Z, okay? I'm going to move that over here. Let me label this Z subscript alpha divided by 2. Okay, so there we go. Z alpha divided by 2 is 1.64. All right, so I'm going to go ahead and write that in. So this equals 1.64, okay? Z is squared. All right, now what is P and Q? Right? What are these guys here, this P and this Q? Well, they didn't tell us any prior estimate of the proportion of people 50 and older that use their cell phone. If you had a prior estimate, then you would put those in for P, and then Q is 1 minus whatever P is. But since they didn't give it to us, we will just put in 0.5. If you don't know, then put in half, right? So half, so P, so it would be times 0.5 times 1 minus 0.5 is Q, so that's times another 0.5. Okay? All right, all that over E. What's E? E is our margin of error, right? And they want the sample portion to be within 3 percentage points of the true population portion. So this is E here, 0.03. So let me put that down here, 0.03, and E is also squared. All right, so let me go into Excel. Actually, let me move this over so I can see it while I'm doing my Excel formula. All right, so my sample size, N. Okay, so let me type in equals 1.64, or actually, instead of typing it, I could have just pressed on that cell, okay? And then done the little caret squared, so that's the Z squared, times 0.5 times another 0.5, or you could have just written 0.5 squared. That would have worked as well. Divided by, let me move this over so we can see it, the margin of error squared. So 0.03 squared. Okay. So we have Z squared times P times Q divided by the margin of error squared. Press enter, and there we have it. 751.53. Now, you always round sample size estimates up. Okay, so we can't have half of a person. We need the whole person. So even if it was 0.03, it's still, we can't have 0.03 of a person. We have to have the whole person. So you always round it up. So 752. Okay, so we need 752 people to participate in this survey. 752.